Okay, so we are going to start chapter 8 with something you should have learned somewhere in middle school called the Pythagorean theorem. We're actually going to start off with 8.2. We're not going to be doing the first lesson, okay? And what we want to do is the Pythagorean theorem and its converse. So as the Pythagorean theorem goes, first thing, what do we need? Our hypothesis is that you have to have a right triangle. Okay, so you need to have a right triangle in order to apply the Pythagorean theorem. So if you have a right triangle, then the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. So let's just remind ourselves the legs are the ones that make the right angle. So A and B are the legs, which makes opposite the right angle. This is the hypotenuse. So again, this is all written out in words, but we know the square of A plus the square of B equals C squared. Again, where C has to be the hypotenuse. Now, A and B can be switched around. It does not really matter which ones you make A and B. These can be reversed. That will be C. That's our hypotenuse. So I want to do 20 squared plus 37.5 squared equals x squared. And note that I said put everything in simplified form. So let's take a look when we do this. And have a calculator handy for this lesson, or you can have Desmos open, whatever works for you. So 20 squared is 400. 37.5 squared is 1,406.25. So I'm going to combine. And then I want to take square root. And actually this one works out if you just type in square root of 1,806.25 into our calculators. So to get to the square root button, if you have the TI Nspire, we're going to press the control button and then the x squared. That'll give us the square root symbol. And then we type in 1,806.25, press enter, and we get 42.5. So that's going to be our answer. Okay, next one. So 5/7 is opposite the right angle, so that's our hypotenuse. So this time it's going to be x squared plus 4/7 squared equals 5/7 squared. Now remember, when we're square fraction, we're going to square the numerator. So 16 over 49 equals 25 over 49. Subtract 16/49 from both sides, so that will give us, oops, forgot my 4 there, 9 over 49. And then when we take the square root of a fraction, we're going to take the square root of the numerator and the square root of the denominator, so that's going to be 3/7. Again, we want to make sure it's in simplified form. Don't change it to a decimal, unless it's an exact decimal like the last one. Okay, so now our converse basically says, now if you have the sum of the squares of the legs of a triangle is equal to the square of the longest side, then our conclusion is the triangle is a right triangle. So if A squared plus B squared equals C squared, then triangle ABC is a right triangle. Okay. And again, C meaning it has to be, this always has to be the longest side. Okay, we want to determine whether PQR is a right triangle. We got 5, we got 6, we got square root of 61. I know I can type in square root of 61, has to be bigger than 6. It's about 7.8 or so. Just so you know that we're going to make this A and B, and we'll make this one C. So I want to see, is 5 squared plus 6 squared equal to square root of 61 squared? So we get 25 plus 36. Now, when I have a square root and I square it, we're just left with what's underneath. Okay. And when I add these together, I do get 61, so that checks out. So this one is going to be a yes. This one's a right triangle. Over here with B, if I type in square root of 11, this is about 3.3. So that means 7 has to be the longest side. So I'm going to check, is the square root of 11 squared plus 5 squared, does that equal 7 squared? So we're going to get 11 plus 25. 7 squared is 49. But what happens when I add these? I get 36. So these are not equal, so this one's going to be no. Again, you'll notice these are all kind of extension of the Pythagorean theorem. The next one is called, it's just a property, Pythagorean triples. These are basically whole numbers that satisfy the equation a squared plus b squared equals c squared. So 3, 4, 5 is called a Pythagorean triple because 3 squared plus 4 squared equals 5 squared. I can give you another combination, 5, 12, and 13, because 5 squared plus 12 squared equals 13 squared, because we get 25 and 144 has to equal 169. Another Pythagorean triple would be 6, 8, and 10, because 6 squared is 36, 8 squared is 64. Add those together, and that equals 10 squared. Again, it's only going to be true for whole numbers. Okay, determine whether each set of numbers can be the measures of a right triangle, then state whether they're a Pythagorean triple. So there's basically two parts here. The first part is, so part 1 is a squared plus b squared equals c squared. And then part 2, are they whole numbers? Okay, so 8, 15, and 16. So we want to see, is 8 squared plus 15 squared, does that equal 16 squared? Again, have your calculators handy so you're not doing this all, writing it down. Just type it in, 15 squared. That's going to be 225. And then 16 squared is going to be 256. Now, just looking at this, 64 plus 225, that is way bigger than 256. So I know that these are not equal. So not a right triangle. And if they're not a right triangle, then automatically, so they cannot be a Pythagorean triple. So just a quick note on this part 2 where I wrote up here. I should have said, if part 1, yes, then you consider if they're whole numbers. But if the first part is no, then it can't be a Pythagorean triple. It has to be a squared plus b squared equals c squared has to be true in order for it to be a Pythagorean triple. Okay, next one. So I want to see is, oops, did not mean to open Equatio. Okay, so I want to, take square root of 3 over 5 squared plus square root of 6 over 5 squared and see if that's equal to 3 over 5. So I get 3 over 25, right? Square root of 3 squared would just be 3, but don't forget you got to square the 5 on the bottom. And then I'll get 6 over 25. Oops, I forgot to put my squared there, and I get 9 over 25. So is this statement true? Yes. So this is a right triangle. However, it's not a Pythagorean triple because we do not have whole numbers. But not okay, so it's a right triangle but does not represent a Pythagorean triple due to the fact that there are square roots and fractions. Okay, next one, we have 20 squared plus 48 squared. Does that equal 52 squared? So 20 squared is 400. 48 squared is 2,304. And this is 2,704. So those are equal to each other, right? Excellent. So is it a right triangle? Yes. Are these whole numbers? Yes. So it's a right triangle and Pythagorean triple. Okay, so D, I can see it can't be a Pythagorean triple because I have square roots and fractions, but let's see if it's a right triangle. So I'm going to have square root of 2 over 7 squared plus square root of 3 over 7 squared, and see if that's equal to square root of 5 over 7 squared. So I get 2 over 49 plus 3 over 49. Does that equal 5 over 49? And the answer is yes. So it's a right triangle. So it's actually like the one above it. So it's a right triangle, but not a Pythagorean triple. Okay, we are going to take that Pythagorean theorem and we are going to adapt it to what happens, or how can we kind of rearrange this to see if we have an acute and obtuse. So if it's not a right triangle, it's got to be an acute triangle where that angle, all the angles are less than 90 degrees, or obtuse where one angle is obtuse and the other two are acute. So really it comes down to taking a look at the longest side. Okay, so we're comparing c squared. If it's less than a squared plus b squared, then we have ourselves an acute triangle. So c squared, it's kind of like compare c squared to a squared plus b squared. So again, less than makes it acute. If c squared is greater than a squared plus b squared, then we have an obtuse triangle. So if it's greater, it's obtuse. And then of course, if it's equal to, then what we did on the previous page, it's a right triangle. Okay, so this is actually the last part. Determine whether each set of numbers can be the measures of the sides of a triangle. If so, whether the triangle is right, acute, or obtuse. Okay, way back last semester, we talked about how two sides of a triangle always have to be greater than the third side. Otherwise, just a quick, like if this was 5 and this side was 1 and this side was 2, this would never make a triangle because the other two sides aren't long enough to meet. So we always have to make sure that the other two sides, so maybe this is 3 and this is 4, that the two shorter sides, when we add them together, have to be bigger than that third side. So first, do they make a triangle? And then we want to determine, are they right, acute, or obtuse? So in other words, how does c squared compare to a squared plus b squared? Okay, so let's take a look at example 4a. So we'll say this is A, this is B, this is C. So first thing, are the two shorter sides greater than the third side? No. So this is not even a triangle. And so therefore we're done. We can't tell if the triangle is acute, right, or obtuse if it's not even a triangle. Next one, so we have 9 and 12. Okay, that's greater than 15, so it is a triangle. Now let's take a look. Let's take 15 squared, and I want to compare that. So I don't know how that compares to 9 squared plus 12 squared. So 225. How does that compare to 81 plus 144? So 81 plus 144 is 225, which means they are equal. Therefore, this must be a right triangle. Okay, this would be A, B, and C. So first of all, does it form a triangle? Yes. 10 plus 11 is greater than 13. Now I want to compare 13 squared. How does that compare to 10 squared and 11 squared? So we get 100 and 121 on the right side. So 169 is going to be less than 221. So if c squared is smaller than a squared plus b squared, this is going to be an acute triangle. That means that angle is going to be less than 90. Okay, last one here, A, B, and C. First, do they form a triangle? Yes. 4 plus 12 is greater than 14. Now I want to compare 14 squared to 4 squared and 12 squared. So 14 squared is going to be 196. We get 16 and 144. But that is definitely greater than, so 196 is going to be greater than 160. So when c squared is bigger, this is an obtuse triangle. And that is it for the Pythagorean theorem lesson.